So good afternoon, everyone, and thank you for joining our 14th webinar of the TAM R&D webinar series. And the topic for today's webinar is architecture overview and key use cases of VMware Cloud Foundation 4.x. So in this session, we'll also try and cover what is new in 4.0 along with the VLCM as well as the skip level upgrade utility. Today we have Hiral Doshi and Amit who will be presenting this webinar. Hiral is a senior product manager at VMware in the Cloud Foundation team. She has 10 plus years of experience, and prior to this, she was working as a product manager in the NSX team. Amit is a staff solutions architect in VMware Cloud Foundation engineering team, and he's been in the IT industry for almost 8 years now. So Amit is going to be panelist and he'll be monitoring the Q&A window. So if you guys have any questions in between, put that on the Q&A window at the bottom of the screen. And then we are constantly monitoring it. We are also recording this webinar. Do get in touch with your TAMs to get the recording and also share it with your colleagues who were not able to make it to this webinar. We'll also try and have 5 or 10 minutes of Q&A depending on the time that we have in the end, where you can unmute yourself and then ask the question directly to both Hiral and Amit. So I think we are good. Hiral, over to you. You can start.
Right, thanks Nitin. So hi everyone. I'm Hiral Doshi. I'm the product manager in the Cloud Foundation team. And as Nitin mentioned, we also have Amit Chatterjee, who is a solution architect in the VCF team and has worked on architecting many complex VCF solutions, especially for many of the VMware strategic customers. So today we'll talk about VMware Cloud Foundation 4.0, the architecture, the features, integration, and towards the end, we'll also have a demo highlighting some of the features. If you guys have any questions, do write in the chat window or the Q&A, and towards the end, we'll have some time to discuss this as well. So this is basically a standard disclaimer slide, though this presentation does not include roadmap items. Just to let you know that the presentation is for information purposes and should not be incorporated in any contracts by any chance. So to start with, we'll just look at basically what are the main features of VMware Cloud Foundation 4.0. So VCF 4 is a complete platform for modern apps. It'll provide you an agile infrastructure to bridge the gap between the app teams and the IT teams in your environment. And so that'll actually help you accelerate the DevOps ecosystem for your business. So VCF is built, like you can see, from the latest and greatest of VMware innovations. So you have the vSphere 7, the V7.7, the vRealize 8, plus the latest NSX-T networking enhancements. And one of the core innovations of VCF 4.0 is VLCM. VLCM provides deeper lifecycle management, which integrate into the qualified vSAN-ready nodes. We'll look more into detail about this in the future slides. And the last, we also have VCF 4 is basically the only release that actually incorporates the architecture of NSX-T in both the workload domain and the management domain. In VCF 3.x, we had the NSX-V incorporated, but in VCF 4, it's just NSX-T. So the NSX-T use cases also apply to VCF 4. It can be used with VCF 4. So the basic features are basically VCF is designed to drive simplification. This would imply that you can support an explosion of apps and data across your different environments. Also, it is standardized, repeatable, and consistent, meaning that it comprises of all the same common components that run in your on-prem, your edge, and your hybrid cloud ecosystem, including the public clouds and cloud services. One of the key features of VCF is it has been designed with intrinsic and intelligent security. So basically security, you can have security in every component, right from the hypervisor through the storage to networking and management layers. We'll look at this and how security applies to the entire VCF stack in the future as well. Now, you can concentrate. So by providing you all these features of simplification, consistency, security, right out the box, you can actually concentrate on building higher value applications for consumption rather than focusing on expanding the infrastructure. So essentially, the innovations can now happen at the speed of the business and can match the business requirements. We'll now see the different VMware products and how they come together to form the hybrid platform. So at the infrastructure layer, you have your ESXi, your vSAN, you have your NSX, and then we have the vCenter that manages the ESXi components. To manage the infrastructure, we have the SDDC manager, from where you can do the deployment, configuration, lifecycle automation, and other functions. And just to call out one of the infrastructure components, the NSX, this is where you perform your switching, routing, firewalling, load balancing, and other NSX features. The vRealize product basically provides the management layer. So it is used to do your operations and automations. And that includes the vRealize operations, login site, automation, and business. So as you can see, we have compute, storage, network, and operations all in one platform. Now, the entire platform can reside on the public cloud and the private cloud, and or it can span across both. Some of the most common use cases where VCF is deployed are DevOps, modern apps, IT automation, VDI, intrinsic security for microsegmentation, and there are many more. So you can discuss your use case with your account team, and you can figure out how this solution can potentially fit your environment. Now, so to start with the architecture of VCF, the VCF has the management domain and the workload domain as the two basic components. So we'll start with the management domain. The management domain has a special purpose, and there'll be only one management domain for each VMware Cloud Foundation deployment. The management domain is where all the management components will reside. So you'll have your SDDC manager, your vCenter server, the NSX manager instance, and the vRealize suite products. All of them reside in your management domain. The workload domain also have vCenter server and NSX manager, and even they get deployed in the management domain. Also, any sort of third-party software, you can actually deploy in your management domain. At a minimum, the Cloud Foundation supports 4 hosts and requires vSAN as a principal storage in the management domain. Beginning with VCF 402, as mentioned, NSX-V is no longer used in the management or the workload domain. It is entirely NSX-T based. Moving on to workload domain, as you can see, each workload domain will require a minimum of 3 hosts. All the 4 is always recommended for vSAN. So each virtual infrastructure workload domain, or the VI workload domain, is a vSphere cluster, and it has its own dedicated vCenter server. Now, each workload domain can have a dedicated or a shared NSX instance with another workload domain. And both the vCenter server and the NSX managers are then placed in the management domain. The sizing of the VI workload domain is based upon the user input and the fault tolerance for your environment. So VMware has the vSAN sizing tools, and you can potentially use that to help you determine the number of nodes that may be required. Now, within a workload domain, we have the concept of creating something called a cluster. So Cloud Foundation supports multiple clusters in a domain. This is very useful when you're running different types of applications within one domain. So you can have app 1 on one cluster, app 2 on one cluster, and they can all fall under the same workload domain. And this actually, the whole concept of cluster even helps a lot with LCM and reduces the time for upgrades and maintenance. And we'll talk more about this going forward. Just to give an example, this is an example of a VCF deployment. So here you'll have the management domain, and you can see the management domain vCenter and NSX manager reside over here. We have shown three workload domains. So workload domain one has two clusters. You have cluster one over here, which is vSphere with Kubernetes, and cluster two, which is some app deployed. Now the vCenter server and the NSX manager for workload domain one is deployed in the management domain. We then have workload domain 2 and 3. The workload domain 2 has one cluster with VDI, and 3 has two clusters, one for app and one for DB. Now, both workload domain 2 and 3 share an NSX instance. And so that shared instance is deployed in the management domain, but each of them will have their individual vCenter. So even those are then deployed in a management domain. So this is primarily to show that you can share NSX instances, whereas for every workload domain, you're going to need one individual vCenter. Now, within each workload domain, you can have a choice of hardware vendors and configurations. So you can map your resources assigned to you. So we may have a VDI workload domain, and it may have security or compliance requirements, or a database workload domain, which may require high performance, or container-based workload domain, which may require more capacity. So you can actually choose your hardware and the different type from different type, multiple type of vendors, and map your workload domain according to what you plan to run on that. We also have the software flexibility, and that includes which products, which versions of the products are part of which workload domain. Now, there is an external interface which can be specific to a workload domain. So you can have your HCX or the external APIs or IP storage or any third-party software, and they can be tied to an individual workload domain. So any third-party tools that you have, like SolarWinds or any sort of data protection tools and more, you can actually deploy using the external API integrations that we have. So there are two basic cloud foundation types. You have the consolidated architecture and the standard architecture. For small environments, customers can utilize a consolidated architecture, and in this, the management and workload domain reside together. For larger environments where a customer would prefer a dedicated resource and RBAC, the customer can choose a standard architecture. So a standard architecture requires a minimum of 4 nodes in dedicated management domain and minimum of 3 nodes for each virtual infrastructure workload domain. It is important to plan and size how many nodes are required. And like we saw before, based on your workload domain type, like capacity, performance, availability, growth, whichever is important, you can select your nodes accordingly. A customer using a consolidated architecture can transition to a standard architecture very easily by adding like more nodes, and using SDDC manager, you deploy a workload domain, and then you can use HCX or vMotion and move your compute VMs to workload domain. So this transition from consolidated to architecture, architecture to standardized, it can actually be done with no time in certain cases. Now, we'll talk a little bit more about consolidated architecture. This design targets smaller cloud foundation deployments and some special use cases. In this design, the management and user domains are together, and we have the vSphere resource pools that are used to isolate between management and workload, management and user workloads. So then as you keep adding additional hosts to a cloud foundation system, you can convert it to a standard architecture. Also, this consolidated architecture, it's very useful, or it's more for customers who want to get started to an entry-level cloud And this provides an option for a smaller entry point in terms of resources, infrastructure needed, and also cost. And then, especially if you're running in robo offices or retail chain stores with a single control plane, the consolidated architecture is a great use. And like mentioned before, you can easily transition to a standard architecture as your requirements grow. Now, the standard architecture is the preferred mode. With the standard architecture, the management and workload domains are separate, and each separate as a vCenter server. So whatever we have seen in the previous slides, other than the consolidated architecture, pretty much applies to the standard architecture. So VMware Cloud Foundation caters to a broad mixture of deployment options. So you are going to have Cloud Foundation can be deployed in the most simplistic form in a single site deployment, where you have one SDDC manager and all your management domain and the workload domain reside there. Cloud Foundation also supports stretched cluster deployments between two sites. And this can be used specifically only when you have vSAN deployed. And then you have the multi-instance management, which allow multiple instances or VCF instances to connect for an aggregated visibility. So over here, it's read only and it's for visibility purposes. But if you have VCF instances at multiple locations, it can all be aggregated and can be viewed from one point. I think we have something in the chat. Okay. Right. So moving to stretch clusters. So just talking a little bit more about this, the way it works is one, we need vSAN. Two, we have, for example, we have two availability zones, 1 and 2, and then we need to have a third site for witness host. The management domain has to be stretched first always. And the clusters in other domains can be stretched. I mean, you don't necessarily need to stretch all the clusters. It depends on what you want between two sites, and you can just stretch those clusters. Clusters, and this is mainly if you want high availability, minimal downtime, load balancing, active DR benefits, and scenarios that you want to deploy for certain apps, or just for certain cluster running, let's say database, and you just want to stretch that between two sites, you can do that. Also, within each availability zone, you can deploy a workload domain. So even in this scenario, it can be deployed in either of them. You don't have to just deploy on site one and you can't on site two. It's pretty much doable on both sides. And again, the whole LCM thing applies to even stretch clusters. You're going to be able to upgrade, expand, delete, all of that in this scenario as well. Um, So now we have mainly two flavors of VCF deployment, main flavors, obviously there are more, but we have VCF on VxRail, and then we have VCF on vSAN ready nodes. So whatever we've been discussing so far applies to both VCF on VxRail, and it applies to VCF on vSAN ready nodes. And whenever there are differences, I'm going to point those out to you. So VCF on VxRail is a unique integration between Cloud Foundation and Dell VxRail across the full stack, right from the hardware, and it has a built-in lifecycle management. So basically, VMware and Dell have a jointly engineered solution which is a VCF on VxRail. And then you can have just one click curated end-to-end stack patching and upgrade. Again, in case of support, there is one support point if there are any issues, which would essentially not be the case if you have some other vendor in the mix. VMware and Dell basically take out the guesswork and uncertainty of patching and upgrading by testing or spending hundreds of hours testing the product version bundles and automating the installation. Now, for vSAN ready nodes, so we can deploy VCF on vSAN ready nodes, which are listed on the VMware compatibility guide. And some of the vendors are HP, Lenovo, Hitachi, the other Dell servers, which are not like the VxRail servers, but if you have others, you can VCF on vSAN ready nodes. If that's part of the list, it can be deployed on that. And then you even, so then you can have a single VCF instance, for example, can have multiple vendors at the workload domain level. So this is a really good feature if you have multiple vendors in your environment and you want to deploy, you want to use those nodes. So it can be a part of the VCF and vSAN ready nodes. It just needs to be a part of the compatibility guide. Also, there's something called the vSphere certified host, and VCF can be deployed on that as well. So all these compatibility guides and hardware compatibility guides is something you can see on the VMware website, and it can give you a sense of what nodes are applicable over here. Now, let's say if you have a brownfield environment and you want to ingest your current deployments into VCF, if the nodes are in the compatibility guides, it may be possible to reimage the host and use them to deploy VCF. So you can work with your account teams to see the feasibility of this particular option for your environment. Moving on to storage. So VMware Cloud Foundation supports multiple storage type and storage vendors. Now we'll talk about storage for VCF and for VCF on VxRail. So for, sorry. Okay, so for VCF on vSAN ready nodes, the vSAN is okay, for both of them actually, you have management domain needs to have vSAN as the principal storage. Now for VCF on vSAN ready nodes, the default offering is vSAN as a principal storage, but you can also have NFS or FC fiber channel as your principal storages. And you can have the vVol block or vVol file as your supplemental storages. But for VCF on VxRail, your principal storage is mandatorily vSAN, and your optional supplemental storage can be NFS. So essentially with VCF on vSAN ready nodes, you have more principal storage options. And in the future, we are working on getting that on VxRail as well. So Cloud Foundation, like one of the key features that we discussed in the beginning is it's a very highly secure platform. And the security is built into every level of the environment. Now let's consider the different layers, right? So you have your container layer. So here you have your Tanzu Kubernetes grid, which includes the best-in-class registry and for built-in vulnerability scanning, image signing, and auditing. Then you have your compute layer, where we utilize the vSphere security features. So we have the vSphere security for protecting data, infrastructure, and access. And it also provides VM level encryption. At the network layer, you have microsegmentation, which provides security at granular individual workload domain level. And so the secure, and one cool thing about NSX is basically your security policies actually travel where your workloads travel. So in case of vMotion or HCX, your security policies will actually, based on your configuration obviously, but it can actually travel along with your VM. Now at the storage layer, Cloud Foundation offers data at rest encryption at cluster level. And our storage encryption is built in for compliance requirements and offers key management. So you can even use external key managers like CloudLink, Hytrust, SafeNet, and others. So this is where the API integrations that SCDC provide can be used. And now with the network and app security add-on for Cloud Foundation, workloads can be protected with the NSX distributed IDS IPS, the NSX Advanced Load Balancer, which can provide a comprehensive protection. Also, we have the Carbon Black. So Carbon Black provides cloud native endpoint and workload protection. This particular slide basically includes the security that are provided in all the components of SDDC Manager. and other VMware solutions like Carbon Black, which you can actually validate with and see how they can fit in your environment and deploy those as well. So new in 4.0 is the SCDC Manager security enhancement that have been done. So we have enhanced security through token-based authentication. So now every public API will need a authentication token. And we have also added new LCM APIs for creation and upgrade of workload domain. One another key features was in VCF 3.x, we only had the admin role for RBAC. But in VCF 4.0, we actually have the operator role and the admin role, obviously. And then in the future, we may potentially add other roles as well. Okay. So as far as ops and monitoring is concerned, um, VCF integrates with the vRealize suite of products. So basically, even here we have actually simplified how you manage your operations and automations on VCF. So your STDC manager will deploy your VRLCM, and then VRLCM will deploy all the different vRealize products, which include the VRA, VROps, VRLI, and even the workspace one, right? And in order to perform operations into any of these products, the customer actually logs into the VRLCM. So there is a single point where they can log in and perform the operations. So this provides consistent experience across all the products on VCF and also provides enhanced support. Okay. This is so life cycle management is basically the crux of any of the VCF solutions. So we'll talk a little bit more detail about the different life cycle management enhancements and what's there right now in the product. So let's start with a scenario to highlight the benefit of being able to perform upgrades and patching at the per cluster level. So right now what happens is when performing ESXi updates with large workload domains, we require large maintenance windows, and you have your host evacuation, host rebalancing, reboots, and so many different things that can take place that actually not only can, but they really do affect, have negative effect on the applications and the capacity for running workloads. So, and quality of service is degraded. In case of issues, the host don't come up, then the application is down for a long period of time. So there are many issues that can, many things that can go wrong. And when you have large workload domains and you're performing updates, that could be an issue. So to solve that, we have actually introduced cluster level upgrade support, which caters to smaller maintenance windows. So you'll be able to perform upgrade and maintenance at a more granular level, which reduces the risk of failures and decreases the time taken to complete this task. And it also allows organizations the flexibility to run different clusters at different ESXi levels. And so you can potentially, a workload domain can have two clusters running same or some similar apps, and you can upload one at a time, so another is always available. There are many more things you can do, and it's a cluster level upgrade options that are provided. Um, then the VLCM, right? Now this is introduced in VCF 7. So VCF 7 introduces an entirely new solution for unified software and firmware management. And VLCM is the next generation, and it's a replacement to vSphere Update Manager. Though at present, both VLCM and vSphere Update Manager are being used, eventually it's going to completely replace it. But as a 4.0, both of them are used for different functions. And basically, this is based more on the desired state or the declarative model. And it provides lifecycle management for the hypervisor, as well as the drivers and firmwares for the server in your vSAN ready node list. So VLCM is a very powerful approach for creating simplified lifecycle management. and it is actually created to with the needs of the different vendors in mind. So what these vendors have to do, they actually have to provide their specific lifecycle updates through a plugin which the vendor manages, and that plugin has to be installed by the customer. So the way it works, let's say right now we have as a 4.0 integration with HP certain servers of HP and certain from Dell, servers from Dell. So each of these vendors have their plugin. They are the ones who create this plugin, and they have the framework for all their firmware and driver updates. And the customer just installs this plugin into vCenter, and that's it. Then you have your end-to-end hardware and software upgrade, which was initially not the case, where you could only do software upgrades, and the hardware upgrades for anything vSAN, which was not VCF from VxRail, you had to actually do it separately. So it uses a desired state model like we discussed, and it monitors the compliance drift and remediates back to the desired state. It also manages host at cluster level, including your hypervisors, drivers, and firmworks. And like I said, currently the two vendors are Dell and HP. There are certain versions of Dell servers and HP, and we can provide them to you, or it's pretty much available on the VMware side. Um, Also, VLCM is limited to vSphere 7. So like it's like, and hence it is a 4.0 feature, because 4.0, VCF 4.0 is actually vSphere 7. And one of the key points is it requires homogeneous servers in each cluster, which can potentially change in the future as well. So now, giving you the difference between VLCM and WUM is that how it basically achieves the results, right? In case of, let's say, in case of VLCM, it actually the image consists of your base image and your vendor add-on and your firmware and driver add-ons. So VLCM is essentially lifecycle management at the cluster level, and WUM provides an upgrade and patch mechanism for individual hosts. So this is primarily a primary difference. One is at the cluster level, one will provide you at individual host level itself. Um, then just to show you the difference between VCF on VxRail and VCF on vSAN ready nodes, right? So whatever we discussed so far was the LCM on VCF on ready nodes. Now VCF on VxRail, considering it's a jointly engineered solution between Dell and VMware, it has a slightly different upgrade mechanism. As you can see, the SDDC manager in this case, it connects to the VMware support site and the Dell support site. And it downloads the VCF bundle and the VxRail bundles, which are both tested and validated by VMware and Dell. So we actually do all sorts of interop testing and making sure all the features are compatible with each of the versions. Uh, One of the difference now, one thing is like, okay, now the other vendors like HP are also providing solution for hardware upgrades. But one of the big differences in VCF on VxRail, you do not need a vendor plugin that has to be installed in your vCenter. And also as far as support is concerned, you have a single point of support for VMware and Dell. You don't need to contact some other vendor and then VMware and patch them all together in case of issues, which a lot of us have experienced when troubleshooting something. So differentiating LCM across the complete stack, you have your vSphere 7 LCM engine, which is basically, it does the update for your hardware stack, which only at present includes Dell and HP. And that too, certain versions of Dell and HP only, can't you, not all of them. And your ESX and vSAN. For VxRail, you have your hardware stack. It does the VxRail manager will do the upgrade of hardware, ESXi, vSAN, and vCenter. And then the full stack LCM is basically your SDDC manager will leverage either the WUM or VLCM and upgrade the VDLI suite and NS6 as well. So the whole this pretty much provides us the end-to-end lifecycle management for any VCF stack that we have. Um, so a couple of features. We spoke about VLCM in detail, and one thing that Nitin mentioned was the skip level upgrades, right? So we currently have a CLI tool where you can upgrade from VCF, any VCF 4 version to the new VCF 4 version that's coming out soon. And this was present in the last few releases of 3.x line, but this is definitely a very integral part of VCF 4.x right from the beginning. So now let's just talk about VMware Cloud Foundation with Tanzu, right? We all think we probably require specialized knowledge of Tanzu in order to do any sort of Kubernetes in order to do these kind of deployments and have concerns about scaling up or scaling down environments and more. So the way it works is, as you can see, we have your VMware Cloud Foundation environment. On top of that, you have your vSphere with Kubernetes, and then you deploy a Tanzu Kubernetes grid. The infrastructure is basically managed by the Cloud Foundation and the vSphere with Kubernetes. The managing and orchestrating of containers, scaling, and all that can be done from the Tanzu Kubernetes grid. And the microservices like load balancer and security can be done by vSphere with Kubernetes. So this is essentially the fastest way to Kubernetes in a hybrid cloud. Also, like you saw, we have a whole lifecycle management of entire software stack, and that could potentially apply as well. Um, Now, a little more on that, right? So just to give, basically VCF will enable you to scale Kubernetes at like the maximum scale, right? Now, let's say for a small team of VCF operators to deploy infrastructure and enable Kubernetes, um, for a small number of developers, it's easy. But as the developers increase, you can also deploy more namespaces and add more workloads. Now, if the environment grows even more and the number of developer continues to increase, or the number of applications in your environment start using this new Kubernetes infrastructure, it'll become necessary to deploy multiple vSphere clusters. And this is where, to do this quickly and at scale, you need the automation of VCF. So like we saw in the beginning, right, it's a very repeatable and consistent deployment type. So it makes it very easy to stand up new infrastructure and deploy. You just deploy a new workload domains, deploy the necessary software required, and can have a Kubernetes environment running. The automation capabilities of VCF together with the Kubernetes capability enables VCF operators to scale the underlying infrastructure, and you don't have, I mean, it helps you more to scale that with the way you would do in a cloud. So with like cloud-like agility, you can pretty much do that with the VCF automation and the native Kubernetes capabilities. A little more about the APIs, because we have a lot of customers who have third-party software, third-party tools that they're using, which they would like to integrate into VCF. And so then the way we have in VCF 4.0, we have introduced public APIs to allow integration into the manager. For example, you can use the developers can use these APIs to commission and decommission infrastructure as a code. Or they can be used, like I said, for if you have any CMPs or ERPs and service management systems, or for integration with any partners, or for service providers, right, who look to leverage the value of on-premise cloud-like platform. So the APIs are a very new public APIs is what we have introduced, and a little more insight is they allow integration of various functions with CI/CD pipelines and also infrastructure as a code solution. So all day zero to day end operations, right, can be performed via the APIs. Now, this would include managing domain operations, workload cluster deployments, host operation, NSX, real-life suite. So pretty much any of the day zero to day end LCM or SSL certificates, password rotation, they all can be done with public APIs. As far as backup and restore, we have a file-based and an image-based backup and restore. The STDC manager, vCenter server, and NSX manager are file-based backups. And the workload domain configuration is done using image-based. We can also use the vSphere storage APIs to back up the workspace one and the real-life suite. So you can essentially back up all the different components of your VCF stack in the product itself. I mean, obviously it goes to a third-party site where you upload your images. So partner integration, right? Now this is what we have seen is we have a lot of customers who are demanding DevOps approach when deploying VCF. So VMware Cloud Builder provides a basic hooks to extend the support to external partners. The customers have the requirements to meet audit and compliance, for example, and a lot of customers use CyberArk. So that is one with which we have integrated. So you can go to the CyberArk marketplace and you can download the plugin to do integration with VCF. Also, the Dell PowerProtect solution is the first to market backup solution for VCF. It fully integrates your SDDC Manager backup restore APIs, and it backs up your management domain, Kubernetes, your workload domain, real-life infrastructure. And in our case, it even, because it's a Dell solution, it even backs up your VxRail manager. So at the end, for VCF on VxRail, this solution provides end-to-end backup. And this week itself, we announced cohesity support for backup. So just to conclude, now this capability is coming basically at the right time. So because we find ourselves in the middle of new disruption, right? So as Kubernetes deployments increase and the IT staff are becoming very overwhelmed with it, most of IT who actually thought they would be able to ignore this entirely, it's actually now the core of the core question. So if I can't ignore this, if Kubernetes and containerized workloads are very much a part of the future, am I really about to stand up a whole separate island of infrastructure? Or do you want to go down that bimodal operations? What if we were told that you don't actually have to get rid of your old infrastructure? What is the product that you need to buy to stitch the old and the new world together, the world of existing infrastructure and the world of cloud-like experience? And this is basically where the VCF comes into picture. So it basically makes it easy to combine these two worlds, and it gives you the ability to automate and streamline a lot of deployment, upgrade, LCM deployment, repetition, or repeating any sort of workload domain environments. So it just gives you a very good control as well as security and visibility. Do a short demo, probably for 5 minutes. We'll show you one is deploying a virtual infrastructure workload domain with Tanzu, and there's a couple of Kubernetes as well. Can someone confirm if you can hear the sound?
In this demonstration, I will show how VMware Cloud Foundation makes it easy to stand up virtual infrastructure in preparation for hosting.
Sorry, can you guys hear the sound?
I can hear.
Okay, good. Okay.
Kubernetes workloads using vSphere with Tanzu. Cloud Foundation provides advanced automation with the VMware SDDC Manager that makes it easy for cloud administrators to deploy infrastructure quickly and in a way that is consistent, repeatable, and scalable. From the SDDC Manager, ESXi hosts are added to the Cloud Foundation inventory. Unassigned hosts represent a pool of available capacity. To provision ESXi host into vSphere clusters, where we will in turn host our Kubernetes clusters, we create workload domains. Workload domains have a standardized architecture comprised of vSphere, NSX, and your choice of storage. In this example, we are using VMware vSAN. We start by assigning a name to the domain along with a name for its first vSphere cluster. A dedicated vCenter server instance gets deployed for each domain. We simply provide the IP address and fully qualified domain name and set the desired root password. Each domain also includes VMware NSX. To deploy NSX, we simply enter the IP address and hostname information for the NSX manager appliances and set the related passwords. As we are using vSAN, we next set the failures to tolerate for the default storage policy. Note that we can optionally enable vSAN deduplication and compression as well. Next, we assign host to the domain. A minimum of 3 hosts are required, and in this example, I have selected 3 hosts. Next, we assign license keys. The vCenter object names for the domain are generated based on the input values we provide. We are able to review the list of generated names and ensure they comply with our naming conventions. We then review the settings, and when ready, click Finish to create the domain. The SDDC Manager combines over 100 separate tasks into a workflow that is executed to automate the domain's deployment. With Cloud Foundation, everything is automated. This includes deploying the vCenter server appliance, adding the ESXi host to the inventory, and creating a vSphere cluster, configuring the virtual distributed switch with its related port groups, and migrating the host networking, creating the vSAN data store, installing and configuring NSX, and adding the host to the NSX fabric. The new domain is created quickly and without any risk of manual errors. Returning to the SDDC Manager dashboard, we see our WLD01 domain. Here we can view details about the domain. For example, we see the 3 hosts and that these 3 hosts are part of a single vSphere cluster. In this demonstration, I will show how VMware Cloud Foundation makes it easy to deploy an NSX Edge cluster in preparation for hosting Kubernetes workloads using vSphere with Tanzu. The Edge cluster provides routing services and enables external network connectivity for Kubernetes and its associated application workloads. Fortunately, with Cloud Foundation, the deployment of the NSX Edge cluster is fully automated. From the NSX Manager, we confirm that NSX has been configured for the cluster. This was done automatically during the domain creation. We will now use the SDDC Manager to deploy 2 NSX Edge transport nodes and configure them into a 2-node NSX Edge cluster. Along with implementing the Edge transport nodes and creating an Edge cluster, the SDDC Manager will also configure logical routing to include route peering using the Border Gateway Protocol, or BGP. From the SDDC Manager domain summary view, we click Actions and select Add Edge Cluster. We see a list of prerequisites needed before deploying the Edge cluster. These include assigning data IDs for the Edge uplink interfaces, ensuring the route peering with BGP has been configured in the upstream network, and having DNS entries for the Edge transport nodes. Confirm the prerequisites have been met and click Begin. We start by providing a name for the Edge cluster, setting the MTU size and the BGP Autonomous System Number, or ASN, and assigning a name for the Tier 0 and Tier 1 logical routers. Note, in this example, we will use the default Edge cluster profile. We then set the passwords for the root, admin, and audit accounts on the Edge transport nodes. Next, we select the workload management use case. Notice the form factor and availability settings are automatically set. We will use BGP for route propagation, so we leave eBGP enabled and click Next. The SDDC Manager will deploy 2 Edge transport nodes. For each node, we assign a management IP address and 2 tunnel endpoint IP addresses, or TEPs. Specify the target vSphere cluster where the transport nodes run and select the cluster type. We then provide the networking and BGP peering information for the first uplink, and repeat this for the second uplink. When done, we click Add Node and see the first transport node added to the list. This completes the input for the first transport node. We simply repeat this for the second transport node. With both transport nodes added, the SDC manager has the information it needs to automate the deployment of the NSX Edge cluster, configure the logical routing, and setting up the BGP peering. We do a final review of the settings and click Next. The SDC manager then validates the input parameters. Upon successful validation, we click Finish. A workflow comprising more than 50 separate tasks will deploy and configure the NSX Edge transport nodes and configure the NSX Edge cluster. Upon successful completion of the workflow, we return to the vSphere web client, where we see the 2 Edge transport nodes deployed inside a new resource pool on our vSphere cluster. From the NSX manager, we again see the 2 Edge transport nodes, which have been configured into an NSX Edge cluster. From the networking tab, we can view the Tier 0 logical routers configuration, including the status of the BGP peering. We can also view the details of the first Tier 1 logical router that was configured as part of the workflow.
Okay, so like you saw, right, everything was deployed in one SDDC manager, and then when we went to the different products, you could see the deployments that were done. We would probably leave some time for Q&A over here. If you guys have any questions, you can unmute yourself and ask. Okay, so just to bring up, we have the VMworld that's coming up next week, and these are some of the sessions that are VCF and VCF and VxRail specific and provide insight into the integrations with Kubernetes, LCM, and all the different other capabilities we discussed today. So you probably want to check them out. And VMworld is pretty much free this year, so you'll have access to a lot more sessions in this. Okay.
Okay.
Other questions?
I don't see any open questions on the Q&A window. I have unmuted everyone. If you are unable to unmute yourself, maybe you can raise your hand so that we can unmute you from your side, from our side. Okay, we have a question here. One second.
Just a question, is this call recorded? Is the meeting recorded?
This is getting recorded, yeah. You can reach out to your TAM to get recording. Yeah.
Okay, sure. Thank you.
Okay, any more questions? Yeah, we have a question from Balan. Go ahead, Balan.
Yeah. So currently we have a traditional network and FC storage, enterprise storage in our environment. So to get into the VCF, what kind of preparation work we need to do on storage and networking stack?
Hey, this is Amit. So for your, so in our documentation, we have some pretty specific planning and documentation guide, which we can provide you. For the networking is if you have an existing vSphere environment, right? So it is similar to, you need all the required configuration for vSAN, vMotion management, NSX, etc. For your storage configuration, so VCF does not actually manage the external storage. So you will need to create whatever LUNs you need to provide and export them as a VMFS to the ESXi host. But it'll be easier if you go through our planning and prep guide.
Okay. For the networking side, do we have kind of any data sheet where we can check the prerequisite and then collect the data, the required data for getting into the VCF?
Yes, so that will be our planning and prep guide. So let me try to post the link in the chat.
Okay, thank you. And related to the storage stack, can we provision the storage or the LUNs upfront to the manager, and then can manager handle the deployment, the workload deployment as and when required, or this has to be a manual task?
Yes, so from your external storage point of view, you need to create LANs and have them exported to the host. When the workload domain is created, it will actually ask you what kind of storage you want to use. So the three options will be vSAN, VMFS, and NFS. Depending upon the option, it will go and expect the LANs to be already be present in the ESXi host, and it will go and configure it. So the storage configuration is the manual that is not done by VCF.
Okay, thank you.
This is Jay. So this cloud supports Oracle Rack shared concepts, shared VMDK concepts also.
I'm not familiar with the Oracle Rack. Nitin or somebody else, do you know?
Yeah, so that is supported. You can have Oracle Rack on vSphere, which is on a VCF infrastructure, and we do support Oracle Rack deployments.
Oracle support on top of VMware. So we have a contradictory statements coming from the vendors, right? So
maybe you can reach out to the TAM or the SE, but then I have customers who are running Oracle Rack on vSphere with VMDK being shared between both the nodes.
yeah,
So
we do have it out. So we are hearing from Oracle as a different conversation. That is the reason. No issue. Thank you.
And yeah, can you hear me?
Yeah, we can hear you well.
Okay, so the Oracle Rack, the agents, there are various agents can be integrated with the workload line, or I mean, like, is there any document out there how we can integrate the agents for, especially for the disk detach and attach function? Some of them are using detach and attach function. So those kind of the coordination work where the agent can talk to the workload vCenter.
So we do have Oracle Rack deployment best practices guide. So when you're talking about VMDKs being shared across nodes, that is possible, but you'll have to configure that in multi-writer mode.
Okay.
If you're looking for a reference architecture, we do have Oracle deployment best practices guide on vSphere. We can share that with you.
Okay, fine. Thank you.
But it doesn't matter if it is VCF, non-VCF environment, you can place it anywhere on VCF, VI workload domain, or on a non-VCF environment. Doesn't matter. Hiral, I have a question. Do we plan to support brownfield insertion of a VVD deployment into VCF?
Yes, so that is something I think someone asked in the chat as well, and Amit mentioned, responded there. So currently we do not have any sort of support like that, but like I mentioned in my presentation, if you have any sort of nodes that are in our compatibility guide, then they can potentially be used to re-image, and it can be used as a part of VCF, but there is no like taking something and making it a part of VCF right now. That is supported.
Okay. And any plans to embed the skip level upgrade utility directly into the SDDC Manager UI
Yes,
instead of?
yes, definitely. It's coming soon.
Okay. Uh, Bala, do you have a question, because you have raised your hand? Okay. Like we don't have any questions on the Q&A window. No hands being raised. Okay, I have one more question. Okay, so today what is happening is when a customer has to upgrade VCF from a specific version to a new version, we are just giving warning to the customer that I hope you have taken a backup of this particular component before you're doing an upgrade. So do we plan to bring that backup restore functionality directly on the SDDC Manager UI, which can then make API calls to all these backup to all these components for them to be backed up? Any plans around that?
So you're saying that I mean, I'm sorry, I don't understand. We do have the backup and restore capability right now, right? That can be used where the
Yes.
funds are backed up to a third party or the SFTP server. So
It
you're
is
saying that we want to make it mandatory for them to back up before any upgrade, or?
correct. It is only there for NSXT where we ask the customers to configure SFTP, but then we are just giving them warning. Hope you have taken a backup of this component, but the actual backup that the customer has to do is still through vCenter server. So since SDDC Manager will be used for all the day two operations, do we plan to bring that capability into SDDC Manager?
So SDDC Manager currently provides the capabilities for other backup products to integrate. So for example, recently there was an announcement which came out from the Dell as to that one of their product is now integrated with VCF deployments, right? That is what is available currently today. But I don't think there is anything in the roadmap to do it from the SDDC Manager side.
Yeah, in particular from the SDDC manager, there's nothing on the roadmap, right?
Got it. Thank you. So one second, I have a question on the chat. Oh, Amit has posted a document on the chat. So I think we are good. We don't have any questions on the Q&A. So Ajish has raised his hand. One second. Just allow him to talk. Yeah, Ajish, you can ask your question.
This is the question I asked already, but I didn't. I think Amit has confused with that. So I would like to ask the networking on the management domain. Is that NSX or we can use the native networking?
It's NSX.
It is NSX.
NSXT, right?
Management domain is mandatory. NSX, yeah.
Okay. All right.
I think even in the VI workload domain, it is mandatory, right?
Yeah, it's NSX, yeah.
It is.
Yeah, that was clear for me. But the management domain
Management
was
domain
not.
as well, you need NSX.
All right. Thank you.
Okay, Hiral and Amit, I think we are good. Thank you very much for this wonderful session. We are recording this webinar, so do get in touch with your TAMs to get the recording. Thank you all. Thank you all for joining this webinar.
Thank you very much.
Thank you.
Thank you.